Hi everyone, my name's Aman and I'm the GCSE Chemistry tutor for the My Tutor online school. Hopefully you were here on Monday where we started with hydrocarbons, and today we're going to be looking at burning hydrocarbons and cracking. If you haven't been in any of my sessions before, hopefully you know that I study medicine at King's College London. I've done all the chemistry sessions with my tutor. Today the session will run for 1 hour from 9:45 to 10:45, and as usual, if you have any questions at all, please pop them in the chat function or in the Q&A, and I'll try and pick them up as we're going along. So if anyone's got any questions now, please pop them in. If not, we'll start. Okay, so as I said, we're going to be looking at hydrocarbons today, especially looking at cracking, that's producing alkenes. So the 4 learning objectives today are to be able to write the balanced symbol equations for complete combustion of alkanes, understand the harms of the production of incomplete combustion, describe the process of cracking, and know the properties of alkenes. So as I said, we looked at alkanes on Monday, so today we'll be looking a bit more on alkanes and then going into alkenes as well, and we will be doing a quiz at the end, so not at the beginning today, but at the end. So just as a recap then of what we covered on Monday, so we looked at the process of fractional distillation, and this is a really key table of all the properties that we need to know about shorter and longer hydrocarbons. So I've got a bit of a fill in the gap exercise. So first of all, does anyone remember when we do fractional distillation, the shorter hydrocarbons, where do they come out on the column? Do they come out at the top or do they come out at the bottom? So the shorter hydrocarbons. Good, they come out at the top, well done. So shorter hydrocarbons at the top. What about the longer hydrocarbons then? We've got top for those, the longer ones. Great, at the bottom, well done. Okay, so if we start with the shorter hydrocarbons and go through those first. So what boiling point do the shorter hydrocarbons have? So they come out at the top. Good, they have a low boiling point. Does anyone remember why they have a low boiling point? What makes them have that low boiling point? So they come out at the top and they have a low boiling point. Excellent. So someone said there's weak intermolecular forces. Really, really good. Well done. So between hydrocarbons, so if we think about, for example, methane, which is CH4, remember there are covalent bonds in methane. So the carbon is covalently bonded to 4 hydrogens. But it's not the covalent bonds that we break when we boil methane. What we break are the intermolecular forces between molecules of methane. And it's these forces that are weak. And because methane is quite a short molecule, there's not many intermolecular forces, and that means there's less energy that's required to overcome those forces. And that's why methane and all the shorter hydrocarbons have a low boiling point. Conversely then, the longer hydrocarbons have what boiling point? If the short ones have a low, what do the longer hydrocarbons have? A high boiling point. Excellent, well done. And the reason for that is the exact opposite. So they are made of more carbon and hydrogen atoms, which tends to mean that because they're longer, the intermolecular forces get stronger. So if you remember a couple of weeks ago when we looked at covalent bonding, you might remember me saying that the longer the molecules are, the more intermolecular forces there are, and therefore the stronger they are. So even though intermolecular forces are weak, if something is longer and there are more intermolecular forces, that will increase the energy required to overcome those forces. So that's why the longer hydrocarbons have a high boiling point. Okay, what does volatility mean? So I've got a clue, it becomes something easily. So what does volatility mean? Anyone remember? Good, it's about how easily it becomes a gas, not a liquid. It's about how easily it becomes a gas. Great, so shorter hydrocarbons, do they have a low or a high volatility? Do they become a gas easily? Good, they have a high volatility, and exactly it's because they do become a gas easily. So we say high volatility and it's about becoming a gas easily. And then conversely, the longer hydrocarbons have a low volatility and it's not easy for them to become a gas. Okay, so the one that most students get confused about is viscosity. So what does viscosity mean? What does viscosity mean? Does anyone remember? Yeah, great. So someone said how flowy it is, how runny it is. That's great. So the only thing I would say about how runny it is, it can be a bit confusing when you're thinking about low viscosity and high viscosity. So the way I try to think about it is kind of how thick it is. It is about how easily it flows. But if you think about how thick it is, then it makes sense that low viscosity means that it's runny, whereas high viscosity means that it's quite thick. And that's just to help you to remember. So what do you think about shorter hydrocarbons? Are they thick or are they runny? What do we think? Yeah, they're runny. So that means what then? Do they have a low or a high viscosity? So they're runny. Do they have a low or a high viscosity? Low viscosity, exactly. So that's why I try to think of viscosity as kind of being how thick they are. It's not, it is about how easily they flow. But if you think about how thick they are, then it makes sense that low viscosity means that they're very runny. And then conversely, the longer hydrocarbons will have a high viscosity and they tend to be very thick. So someone's just asked me, why do shorter hydrocarbons become a gas easily? That's a really good question. And it's essentially to do with the intermolecular forces. So in shorter hydrocarbons, there's less intermolecular forces, so there's less energy required for them to become a gas. So because they have that lower boiling point, it means that they can become a gas really easily. Whereas the longer hydrocarbons, it requires a lot more energy to almost burn them so that we can get them to become a gas. And that's why high volatility for the shorter hydrocarbons and longer hydrocarbons have a lower volatility. So it's all about the energy and the boiling point involved. Does anyone remember the reason for viscosity? Why are the shorter hydrocarbons runny and why are the longer hydrocarbons thicker? Does anyone remember? So this one's a bit more difficult to explain. And the example I used, yeah, great. So someone's just remembered the example I used. So think of it as a chain. So if we think about it as a chain, if you think about a shorter chain is less likely to become tangled up. So if you think about it that way, it's more likely to flow quite easily. Whereas a longer chain is more likely to become tangled up. So it tends to be a lot thicker, a lot more kind of sludgy. And so that's one of the main kind of reasons that I always think of. In terms of exam questions, they're not that likely to ask you why. They're more likely to ask you for the definition of viscosity and also to be able to compare a shorter hydrocarbon to a longer hydrocarbon. And we did do some exam questions on Monday. So hopefully that's helped to understand what you need to cover to understand that. So as I said, it's to do with chains, but if you want the official answer, it's essentially to do with kind of the intermolecular forces again. So when you've got a low viscosity and shorter hydrocarbons, there's less bonding between the molecules, and that means that they can move a bit more freely. Whereas with the longer hydrocarbons, there's a lot more intermolecular forces there. They're a little bit more fixed, and that makes it harder for them to move. So it all comes down to the intermolecular forces, really. And then the final one, what is the word for burning easily? Flammability. Excellent, well done. So flammability. So do the shorter hydrocarbons have high flammability or low flammability? And why? Good, they have a high flammability. Why do they have a high flammability? Does anyone remember why do the shorter hydrocarbons have a high flammability? Again, yeah, it's to do with the weak intermolecular forces. So the reasoning for most of these is to do with the intermolecular forces and the bonding. So great. So the word here is flammability. And then conversely, the longer hydrocarbons have a lower flammability. Okay, really well done, everyone. It seems like most people remembered most of that from Monday. If you are a bit confused on fractional distillation and you want a bit more information on it, please go back to Monday's lesson because we're moving on a bit today. But very well done, everyone. Any questions on that before we move on to today's kind of objectives? Okay, as I said, just pop them in the chat function or the Q&A if you do have any questions as we're going along. So today we're looking at combustion. And combustion is essentially how we burn hydrocarbons. And specifically today, we're looking at alkanes and the burning of alkanes. So when the lighter hydrocarbons burn in air, by lighter, I mean shorter hydrocarbons. So we're thinking methane, ethane, propane, butane. So the first four, remember they're the four that you need to know in the exams. You need to be able to draw them. You need to know the chemical formulae for them, and you need to be able to name them. They will produce carbon dioxide and water. So that is complete combustion. Complete combustion will produce carbon dioxide and water. So if I just zoom in a bit, so you can see I've given you an example there. I've given you methane and oxygen produces carbon dioxide and water, and this is a balanced equation. So we've got one carbon, four hydrogens, four oxygens, 2 plus 2 oxygens is 4. So it's really important. They do tend to put these in exam questions that you need to be able to balance them as well. So if you remember complete combustion, which means that there's plenty of oxygen in the air that allows the hydrocarbon to burn, will produce carbon dioxide and water. Someone's asked me, what's an alkane? Really good question. An alkane is a hydrocarbon, and a hydrocarbon is something that contains only hydrogen and carbon. So the first alkane is known as methane. So it contains CH4, so you can see it's only got carbon and hydrogen in it, and it's saturated. And what I mean by saturated is that all the bonds are single bonds, and that means it has the maximum number of hydrogen atoms that it can. So for example, methane is drawn like this. And we can't have any more bonds there because carbon has 4 electrons in its outer shell, which means it can share 1 electron with every hydrogen atom. So it's essentially a saturated molecule. Nothing else can be added on. It's completely full if you want. So that's an alkane. And the general formula for alkanes that we went through on Monday is CnH2n plus 2. Just as a quick aside then, if I tell everyone that I've got a alkane with 15 carbon atoms, what's the formula for that alkane? It's got 15 carbon atoms. What's the formula? Good, C15H32, excellent. And that's just manipulating this equation here. So Cn, so the n is 15. We do 2 times 15 because we've got the h's are 2n plus 2. So 2 times 15 is 30, plus 2 is 32. So it's C15H32. Well done, everyone that gave me that answer. Excellent. So back to kind of combustion then and complete combustion. The shorter hydrocarbons will tend to do complete combustion. There'll be lots of oxygen there. They will completely be oxidized to produce carbon dioxide and water. And in this case, when we talk about oxidation, it is actually just the addition of oxygen. So the methane is being added to oxygen to produce carbon dioxide and water. The test for carbon dioxide is that it turns lime water cloudy. So that's a classic school experiment. And it's really important that you know that test, just like all the tests we went through last week, where we talked about the test for oxygen and we talked about the test for water as well. So there are 2 tests for water. The one we talked about last week was anhydrous copper sulfate turning blue. There is one more, and that is blue cobalt chloride paper turning pink. So when you do these experiments, often in exam questions, they might ask you, well, what's the test for carbon dioxide and what's the test for water? Because they're the products that are produced. The subtitle for this slide is complete combustion. So we're looking at complete combustion at the moment. Someone's just asked me, what do we need to know for the exam? So you need to know the first 4 alkanes. So from Monday's lesson, you need to know the first 4 alkanes. You need to be able to draw them, name them, and write the chemical formulae for them. So that's methane, ethane, propane, and butane. As I said, we went through that on Monday. And you need to know the process of fractional distillation. And today we're looking at complete combustion and alkenes. So you need to know all of this as well. None of this is higher tier, just to say, this is in both tiers. So all of this is relevant to all the exams. Okay, so carbon dioxide and water are produced when we do complete combustion. And these are the tests for carbon dioxide and water. So let's have a go then at writing the balanced symbol equations for the combustion reactions of these alkanes. So propane first. What's the chemical formula for propane? Does anyone remember how many carbon atoms in propane? What's the chemical formula for it? Brilliant. C3. It's not an alkene. So someone said C3H6. Remember, it's not an alkene, it's an alkane. Yep, so C3H8. Excellent, well done. So propane is the 3rd alkane. So C3H8. 2H8. Then when we do complete combustion, we add it to oxygen. So O2, remember oxygen always goes around as a gas in pairs. In complete combustion, we always produce carbon dioxide and water. They are always the products in complete combustion, and all of the shorter hydrocarbons will undertake complete combustion. Someone's asking for the difference between an alkane and an alkene. I'm going to cover that in a couple of slides, so I'll go over it then. So let's try and balance this then. If we have a look, we've got 3 carbons on the reactant side, but only 1 on the product side. So let's make that a 3. Now we have 3 carbons. The next thing that I would balance is the hydrogens. So there are 8 hydrogens on the reactant side. On the product side, there are only 2. So if we put a 4 here, that makes 8. And now the final thing we need to balance is just the oxygens. So if we have a look on the product side, there are 3 times 2, which is 6, and 4, which makes 10. So we just need a 5 here. Now what you'll find is that the odd alkanes, by odd alkanes, I mean if they've got an odd number of carbon atoms, are much easier to balance. The even alkanes, so when they've got an even number of carbon atoms, are a little bit more tricky. We're going to do an even one now, but the odd ones tend to be much easier. And my rule for kind of doing the balancing is to start with carbon, then do hydrogen, then do oxygen last. That's my general rule for balancing these combustion reactions. So carbon, then hydrogen, then oxygen. Okay, so let's do ethane then. Does anyone remember the chemical formula for ethane? I've already told you it's going to be even. Good, C2H6, excellent, well done. So C2H6. So again, C2H6 going to burn in plenty of oxygen, and it's going to produce carbon dioxide and water, the products of complete combustion. So if we start off with the carbon atoms first, we can see that there are 2 on the reactant side. So let's put a 2 here on the product side. Then we do the hydrogens. There are 6 on the reactant side. So again, we're going to put 3 here to make 6. Now this is where we reach our problem. Hopefully you remember that when we balanced equations, we don't like putting fractions in, we like whole numbers. So our problem is with oxygen, because if we have a look on the product side, we've got 2 times 2, which is 4, plus 3 times 1, which is 3. So 4 plus 3 is 7. Now we can't make this a 7 unless we put in a fraction. So what that means is we need to double everything. So at the moment, this is 7 over 2, because we want it to equal 7. And if we do 7 over 2 times 2, that gives us 7. So to make it balanced and all whole numbers, we just multiply everything by 2. So what it's effectively going to be is 2C2H6, 7 O2, 4 CO2, and 6 H2O. So I'll write that out again. So 2C2H6, so 2 ethanes plus 7 oxygens will produce 4 carbon dioxides and 6 waters. And that's really common that when we do our even alkanes, often you need to be able to balance it by doubling. And that's just because of the way that it works with oxygen. But if you do it, as I said, go carbon, hydrogen, oxygen, you'll still be able to do it. Any questions on the complete combustion of alkanes? From what I've seen in exam questions, either they'll ask you to do the complete combustion of the first 4 alkanes, so remember methane, ethane, propane or butane, and you write them out yourselves, or they will give you an alkane already on there, something that's probably got a higher number of carbon atoms that you're not expected to know, and then you just need to write out the carbon dioxide and water and balance it. So that tends to be what they do. But any questions on that before we move on to incomplete combustion? So that's complete combustion, carbon dioxide and water is produced. Okay, so let's go on to incomplete then. So incomplete combustion happens when there's not enough oxygen. So we talked about complete combustion. When there's lots of oxygen, we produce carbon dioxide and water. And the key thing is that water is still produced when we do incomplete combustion, but there are 2 other products that may be produced. You will get one or the other. And the other 2 are carbon monoxide or just carbon. So as I said, you will get one or the other. So you will either produce carbon monoxide and water or carbon and water. Carbon monoxide is still a gas. Carbon tends to be a particulate, so it's a bit of a solid. So the first question on the screen is asking, why is carbon monoxide toxic to our red blood cells? So you may have covered this in biology, or if not, think about what's the role of our red blood cells in the body, and why do we think that carbon monoxide is toxic? Any ideas? What makes carbon monoxide toxic? Great. So someone's saying it reduces the amount of oxygen the red blood cell can carry. Great. Yep. It decreases the carrying capacity of oxygen. It prevents oxygen being carried. Great. Really good. So, yep, someone's mentioned hemoglobin. So remember, it's the hemoglobin which will bind to oxygen in the red blood cell. And what happens is that it decreases the oxygen carrying capacity of the red blood cells, and it also can damage the red blood cells. So the reason we say it's toxic to red blood cells is because it decreases the oxygen carrying capacity, which means that there's less oxygen going around our body. And often then that means we can get sick. So people tend to get symptoms of headaches and feeling generally very unwell. It used to be a case in the olden days that our boilers used to produce carbon monoxide. And so people who had dodgy boilers would get carbon monoxide poisoning. Nowadays, the newer boilers don't have that. So it's very rare nowadays to get carbon monoxide poisoning. Is carbon dioxide as toxic as carbon monoxide? So carbon dioxide is not toxic. Carbon dioxide isn't great for the atmosphere, but it's not toxic to our human bodies. We breathe it out. So it is always in our cells. It's not toxic. Carbon monoxide is very toxic. Great. What about carbon then? Carbon particulate, it's called. Does anyone know why that's toxic? Any ideas? What does carbon do? It's not to do with the red blood cells. Any idea? So I've told you it's like a solid. It's a particulate. What do you think? If it's in the air, it's a bit like a solid, like little granules almost. What do you think it could do? Okay. Okay, great. Someone said it builds up and blocks the airways. Really good answer. Yeah. So essentially it lines the lungs and it can irritate them. So people that have asthma, for those of you that don't know, asthma is kind of a chronic condition of the lungs that can cause breathing difficulties. So if you have asthma, it can be really bad. But essentially it lines the airways, so your lungs, and it makes it more difficult for you to breathe. And that's because it tends to be more of a solid, so you tend to breathe it in. Whereas carbon monoxide, because it's a gas, it can go into the bloodstream. Carbon cannot, because it's not. It's a particulate, it's a solid, so very, very fine solid. Is asthma genetic too? Very good question. So there's lots of science on this that people think asthma is genetic. Asthma does not tend to be genetic. It tends to be, it actually starts off as something called a hypersensitivity reaction. So essentially your body reacts to or something in the air that then causes asthma. Someone's also asking, can you die from carbon monoxide poisoning? You can if it's not detected quick enough, yes, because essentially your red blood cells stop carrying oxygen as well as they should be able to, and that means less oxygen is carried around the body. Really good questions. So let's just recap this slide then. So complete combustion produces carbon dioxide and water. Incomplete combustion happens when there's not enough oxygen and we produce water and carbon monoxide, or water and carbon. In exam questions, they will tell you what is produced. They won't expect you to know. Usually they'll say, oh, carbon monoxide is produced or carbon is produced. Other exam questions that I've seen will ask you that when we do incomplete combustion, there are products produced that are harmful. What are these products and what do they do? And so that will just be saying that it's carbon monoxide and that decreases the oxygen carrying capacity of red blood cells, or carbon and that lines the lungs and makes it difficult to breathe, or it irritates the airways. And both of those would be great answers. So let's go on to write some incomplete combustions then. Sorry that this slide's messed up a little bit, but the first one says butane producing carbon monoxide. So what's the chemical symbol for butane? Sorry, the chemical formula for butane. Excellent, C4H10. So butane is the one with 4 carbon atoms, so C4H10. It's still going to react with oxygen. Remember, this is still combustion. It's just there's not enough oxygen. And we've been told it's producing carbon monoxide. So what's the chemical formula for carbon monoxide? Anyone know? So carbon dioxide is CO2. Di means two. What does carbon monoxide mean? Yep, CO1 or just CO. Excellent, well done. So monoxide just means one oxygen. So CO, we don't write CO1, but it is effectively one oxygen. Well done. And what's the other product when we do incomplete combustion? Carbon monoxide and water. Excellent, well done. So always water is produced. Okay, if we go through the rule again, then we balance our carbons first, then our hydrogens, then our oxygens. So there are 4 carbons on the reactant side, so let's put a 4 on the product side. Hydrogens, there are 10, so let's put 5 on the product side to make it 10. But again, we reach this problem where we're going to have an odd number of oxygens. So there are 4 plus 5, which makes 9. So essentially, this would be 9 over 2. Because 9 over 2 times 2 gives us 9. So we need to double everything again. So that means the actual balanced equation is 2C4H10 plus 9O2 goes to 8CO plus 10H2O. And that's the fully balanced equation for that. Everyone that gave me the answer to that, very well done. You were correct. If water isn't produced, can't the carbon mix with the water? I'm not sure what you mean by that. So water is always produced when we do combustion, even if there's not enough oxygen. Okay, so let's do the next one. Propane producing carbon. So we've already talked about the chemical formula for propane. So what's propane? Someone's given me a chemical formula for pentane. Pentane is C5H12, but propane is C3H8. Excellent, well done. So remember, pentane is with 5, whereas propane is with 3. Someone's asked, what is the definition of combustion? So remember I said that combustion, sorry, let me go back to this slide here. So combustion is about burning in oxygen. That's what combustion is. It's when we burn a hydrocarbon in oxygen. Okay, so that's propane producing carbon. So C3H8 plus oxygen again. Does anyone know the chemical formula for carbon? What is particulate carbon? How do we write that? Yep, C. Good, it's just C on its own. So carbon like that. And what's the other product? Carbon and water. Excellent, well done. Okay, so this one's slightly easier to balance because again, it's an odd number of carbon atoms. So if we've got 3 on the reactant side, we put 3 on the product side. Then look at hydrogens. There are 8 hydrogens on the reactant side. So let's put 4 on the product. So 4 times 2 is 8. And the final thing we need to balance is oxygens. And we can see that there are 4 oxygens. So we just put a 2 here. So that one's nice and easy to balance. So when it's an odd number of carbon atoms, it's always a bit easier. Someone's asking, if you were to conduct the incomplete combustion of an alkane, would the carbon monoxide dissolve in the water if left for long enough and at the correct temperature pressure? Would the product of this be a carboxylic acid? So that's a really good question. When we undergo combustion and incomplete combustion, often the water that's produced is actually a bit of a gas. And so what happens is the water and the carbon monoxide will not react because carbon monoxide is a gas. And so the gases will actually tend not to react. And it's the same when someone's asked me, does carbon monoxide react with the water? Again, it doesn't tend to react. So no, they won't react together. They are the products of incomplete combustion, and the products of complete combustion are CO2 and water. Someone's asking me if I've frozen. Is anyone else having that problem or not? No? Okay, great. That's fine. Okay, I think just one person's having that problem. To the person that's finding me freezing, maybe restart and join again and see if that solves the problem. Okay, so we've talked about complete combustion producing CO2 and water, and incomplete combustion producing either carbon monoxide or carbon and water. So now that we've covered combustion, let's think about cracking. So I remember on Monday, a lot of people were asking, well, how do you produce the smaller hydrocarbons or the smaller alkanes, such as methane, ethane? You know, when we do fractional distillation, we produce petrol, we produce petroleum, and all these different products. They're not the smaller alkanes. Well, the process is cracking. And so the smaller hydrocarbons can be used as fuels or feedstock. Feedstock's just a fancy word for raw materials or the starting materials that happen in industrial processes. But the larger hydrocarbons are not that useful. So often we want to crack these larger hydrocarbons into smaller hydrocarbons. And that process of breaking them down is called cracking. And as it says here, this is the process where heavy fractions from the fractional distillate are made into smaller molecules, such as propane and some unsaturated hydrocarbons. So what does unsaturated hydrocarbon mean? So we talked about saturated hydrocarbons on Monday, being that there's single bonds and there are as many hydrogen atoms as we can have there bonded. What does unsaturated mean? So it's not about all of the bonds not being used. It's essentially that there's a double bond there. So the unsaturated hydrocarbons tend to be alkenes. And someone asked me, what's an alkene? So before I answer that question, does anyone know what's an alkene? How can we describe an alkene? What's an alkene? So we said alkanes, they're hydrocarbons that are saturated. Excellent. Alkenes tend to be hydrocarbons that are unsaturated and have a carbon-carbon double bond. So I'm going to draw them all out on the next slide. But first of all, let's just go over one of them. So the first hydrocarbon that's an alkene is ethene. The reason there's no methane is because methane only has one carbon, so it doesn't produce an alkene. An alkene needs to have a carbon double-double bond. In methane, there's only one carbon, so it can't produce a double-double bond with another carbon. And that's why the first hydrocarbon that's an alkene is ethene, which is double bond C and hydrogens like so. And the reason there's only two hydrogens is because, remember I said that carbon can only form 4 bonds, so it produces 2 in the double bond, 1 to hydrogen here, 1 to hydrogen here, that's 4, and this one has 2 in the double bond, 1 hydrogen and 1 hydrogen there, that's 4. So what we can see is that is unsaturated because it could have more. If we broke that double bond, it could have 2 more hydrogens, and that's why it's called unsaturated. Excellent to the people that have given me the answers for alkenes. So just a quick recap of what cracking is. So we do cracking to the fractional distillate that comes off when we do fractional distillation of crude oil to produce the smaller molecules such as propane and alkenes. And in exam questions, they would never expect you to know what's produced from cracking, but they will ask you questions that make you have to almost work it out. So we'll do a couple of those questions in just a second. But before we do that, let's just go through the process of cracking. There are 2 types of cracking. The first type of cracking uses a temperature of 550 degrees and a something known as zeolite, which contains aluminium and silicon oxide. Any ideas what's the first type of cracking? Good. Someone said catalyst. Good. So the second word is catalyst. Well done. So zeolite is a catalyst. So it speeds up the rate of reaction without being used up itself. Good. So that's what a catalyst is. Any idea what that type of cracking is called? If it's got a catalyst in it, what do you think we might call it? It's got a catalytic. Yep, catalytic. Well done, everyone that gave me that answer. Excellent. Really good job. So catalytic. So catalytic cracking uses a temperature of 550 degrees and a catalyst, which is always pretty much zeolite, and zeolite contains aluminium and silicon oxide. You don't need to know for exam questions what it contains, but you do need to know the catalyst, and you do need to know that there are 2 types of cracking. So catalytic cracking. The second type of cracking, first of all, doesn't have a catalyst, and that's why the temperature needed is much, much higher. So you can see it's 800 degrees for this type of cracking, whereas when there's a catalyst, it's only 550 degrees. And remember, that's because catalysts increase the rate of reaction by finding an alternative route for the reaction, which ends up by reducing the activation energy. So that means less energy is needed. Any idea? Someone said hydrocracking. You're very close. Very close. Yep, it's called steam cracking. Well done. So steam. So it's mixed with steam and a high temperature, and essentially it's called steam cracking. So there are two types of cracking then, catalytic and steam. The catalytic cracking, lower energy and uses a catalyst known as zeolite. The steam cracking is mixed with steam and a high temperature. Again, you just need to know the two different types, and remember that the reason there's a lower energy in catalytic is because there's a catalyst, whereas the steam energy tends to have a higher energy required, and that's just mixed with steam and a high temperature. Excellent. So this is just an example of some questions that may be asked. So hydrocracking is also an example. There must be three. So the two that you need to know for pretty much all the exam boards is catalytic and steam cracking. It might be that you've heard steam cracking known as hydrocracking because steam is technically water. So it's possible then that you've seen that come up. Okay, so let's now think about this question here. So write an equation for hexane being cracked to form butane and ethene. Hexane being cracked to form butane and ethene. So first of all, does anyone know the chemical formula for hexane? If I tell you there are 6 carbons in hexane, good, C6H14, good. It's being cracked, which means it's being broken down. So we just do the broken down, it's just an arrow. And it's forming butane and ethene. So butane, does anyone remember what's the chemical formula for butane? Someone's already written out the whole equation for me. You are correct, well done. Yep, C4H10 is butane. And then the other product is ethene. What's the chemical formula for ethene? C2H4, excellent. So now we just need to make sure it's balanced, and it is balanced. So if you have a look, there are 4 carbons plus 2 carbons, which makes 6, and there are 6 on the reactant side. There are 14 hydrogens, 10 plus 4. So you never need to really balance these equations. They tend to already be balanced. So well done, everyone. So that's kind of one of the easier questions where they give you all the products and the reactants used. The harder question is one like this. So we're being told that we've got an alkane with 16 carbons. It's used as the starting chemical in cracking. One of the products of cracking this compound is an alkane which has 10 carbon atoms. Write a balanced symbol equation for this cracking reaction. And what they would do in the exam is they would tell you that there is one more product. So there's 2 products. One of them is an alkane with 10 carbon atoms, and there's something left over that we need to be able to decipher. And it's essentially just a bit of maths, really. So if we start off with C16H34, we crack it, and we know we're producing a alkane with 10 carbon atoms. So what's the alkane with 10 carbon atoms? What's the chemical formula for that? Excellent. Someone has said C10H22. Brilliant. So remember, the general formula is CnH2n plus 2. Someone's asking me, is this a year 10 subject? Yes, this is year 10. So excellent. So C10H22. And then using mathematics, what we can see is if we've got 16 carbons on the reactant side, but 10 on the product side, that means there are 6 carbons left. So what we're going to produce will have 6 carbons. And then if we look at the hydrogens, there are 34 on the reactant side and 22 on the product side. So that means 34 minus 22 is 12. So C6H12. Does anyone know what's the name of that? C6H12. You don't need to know. It's an alkene. Great. The person that's tried to name it, you've named an alkane. So it's not hexane. Hexane is an alkane. What's the ending for alkenes? Hexene. Excellent. Well done. So remember, ane is the alkane ending, ene is the alkene ending. So yep, hexene. Well done. Really good job, everyone. That was pretty tricky. So as I said, that's one of the harder types of questions where you have to work it out, but it doesn't get much harder than that. They would never expect you to know the products. They would always tell you one or both. Excellent. Well done. Okay, so the final thing we're going to look at today then is alkenes themselves. So we've said they're unsaturated. They've got that double carbon bond. We've said that they're useful as feedstock for the petrochemical industry. Remember, feedstock means that they are raw materials that are used for the petrochemical industry. They are technically, they're produced from crude oil, so they are non-renewable. They tend to be more reactive than alkanes. Any idea why? Why are alkenes more reactive than alkanes? Does anyone know? Excellent. Someone said because of the double carbon bond. What is special about the double carbon bond? Why does that mean that they are more reactive? Does an alkene have the same general formula as an alkane? Nope. I'm going to go through that in just a second. What's special about that double carbon bond? Someone said it means when it's broken, it can react with another element. That's true, but that's not why they're more reactive. What's special about the double carbon bond? Okay, that's fine. So no one's given me the answer to that. So it's essentially to do with the electrons. So in a single carbon bond, remember, that means that only one electron is shared from the carbon. And so if we think about ethane, for example, let's draw ethane, you can see that it's a single carbon bond. And so that means that there's only one electron shared between the carbon atoms. But when there's a double carbon bond, such as in ethene, what we have is 2 electrons shared per carbon atom. And because there's more electrons there, it makes it more reactive. So the more electrons that are there ready in that bond, the more reactive it is. And you'll learn about this in A-level chemistry if you carry on to do it. And it's essentially that a double carbon bond is shorter and has more electrons in it, and that makes it more reactive than the single covalent bond, which is longer and essentially is not as reactive. But as I said, you'll learn more about that at A-level. You don't necessarily need to know at GCSE, but just in case they do ask you, it's all to do with the double bond having more electrons in it, which they could ask you because technically you learn about double covalent bonds when we do the covalent bonding, structure and bonding topic that we did a couple of weeks ago. So we've said that they're unsaturated because they've got the double carbon bond. We've talked about them being the raw materials for the petrochemical industry, and we've said that they're more reactive than alkanes. The next thing we need to know is that they react with bromine water and turn it from brown to colourless. Now, what's really important is that's not the test for an alkene. That is the test for a double carbon bond. So often in school, you'll do this test where you will see if you've got 2 beakers full of, say, one's an alkane, one's an alkene, you'll add bromine water to detect which one is the alkene. So I've got a YouTube video, so let's watch that then to hopefully make that. Oh, okay, that didn't work. Just give me a second, I'll see if I can sort this out. Okay, while I'm trying to sort this out, does anyone know why the general rule for and what the general rule for an alkane is and what the general rule for an alkene is? The general rule for alkene is on the screen, but someone asked me before about the general rule of an alkane. So if someone could type and tell me what that is while I try and get this YouTube video to work. Good, so the general rule for an alkane is CnH2n plus 2. Whereas an alkene is CnH2n, and it's because of that double covalent bond. So you double the number of hydrogens in an alkene, whereas in an alkane, it's double plus 2. So I can't get that YouTube video to work, so we might have to watch it tomorrow morning instead. Sorry about that. But essentially in the video, it was just going to show you an alkene turning from brown to colourless. So let me just try and draw the first couple of alkenes then. Let me see, I'll try again. Oh, that's why it's not the right link. Okay. Just give me a second, I'm just trying to find the link again so I can show you. Okay, so hopefully this time it will work. Okay, there we go. So we're identifying alkenes. On the left, you've got an alkane. On the right, we've got an alkene. So let's start off then. So as I said, we're going to have an alkane on the left, which is just here now. And on the right, we have an alkene, and this is bromine water. And this scientist is going to add bromine water to both, and we're going to see what happens. So he's going to start by adding or pipetting the bromine water and adding it to the alkane. And what we can see is it remains that brown color. It's not going to become colorless, it remains brown. Whereas when he now adds it to the alkene, you can see it's gone colorless. You form 2 layers, which becomes colorless. So that's the test for an alkene or a double covalent bond. So the alkane was on the left and the alkene was on the right. So the double carbon bond is what you test for when you add bromine water. And if there's a double carbon bond in your beaker, then it will go colorless, the bromine water. Whereas if it's not a double covalent bond, it will stay brown. Excellent questions. So just before we do our quiz then, let me just draw the alkenes for you. So we've done ethene. The next one is then propene, which has 3 carbon atoms. So remember, 1 double bond, and then we draw our hydrogens. So it looks like this. And there should be 4 bonds everywhere. So if we have a look at this carbon atom, 1, 2, 3, 4, this one, 1, 2, 3, 4, this one, 1, 2, 3, 4. So that's propene, which is C3H6. What's the 4th alkene known as? So we've done ethene, the 3rd alkene known as. So the first one is ethene, the second one is propene, the 3rd one is butene. Excellent. Butene, C4H8. So double carbon bond, and then 2 single bonds, and then again, make sure everything is 4. So this is butene, which, as I said, is C4H8. And again, 4 bonds there, 4 bonds there, 1, 2, 3, 4 bonds there, 1, 2, 3, 4 bonds there. So that's C4H8. And the final one you need to know, the 4th alkene is known as what? Does anyone remember? So butene is the 3rd one. I know it's a bit confusing because it has 4 carbon atoms, and that's only because methene isn't an alkene. So the first one is technically ethene. Good, it's pentene. So pentene has 5 carbon atoms, so it will be C, double bond C, and then 3 single bonds. And then again, just make sure everything has 4 bonds. Like so, and then it will form C5H10. So it's just double, whereas an alkane pentane will be C5H12 because it's double plus 2 for the hydrogen atoms. So again, just check there's 4 bonds. So 1, 2, 3, 4, 4, 4, 4, 4. So that's C5H10. And you need to be able to draw the first 4 alkenes. So well done, everyone that gave me the names of those. So just as a recap, they are ethene, propene, butene, and pentene. Okay, so someone's asking, do we need to know prop-1-ol? Prop-1-ol is an alcohol. You will go into what the 1 means at A level. Essentially, if you want to know why we have the 1, it's to do with isomerization. Isomers are different types of the same alkene or alcohol in the case that you gave me there. So if I just show you, if we look at butene, can you see that the double bond that I've put here could technically be in the middle? It doesn't have to be there. That means that there are 2 different types of butene that you could produce. You could have but-1-ene, where the double bond is on the 1st carbon atom, or but-2-ene, where the double bond is on the 2nd carbon atom. This is not something you need to know at GCSE. It's something that you would do at A level. Someone's asking me, would you recommend chemistry at A level? I absolutely loved it at A level. It was one of my favorite subjects. It is quite tricky. I would say that you do go into quite a lot of tricky stuff, but if you enjoy chemistry, I would recommend doing it. And I say that for all your A levels. When you're choosing your A level choices, choose subjects that you enjoy. Don't do subjects that you're not going to enjoy. That's definitely something I'd say, because A level, it can be quite tricky. It's a big step up from GCSE. Okay, so well done everyone. Today, let's now do a quiz. So I'm not using quizzes today, I'm using Mentimeter, and that's because I know you don't have to register. So I'm going to go on to Mentimeter, and all you need to do is go on to menti.com and type in this code 560364, and it should let you into the quiz. I'll wait a couple of minutes for people to do that. So you just go on to menti.com and type in that quiz code there. And I think I've got 8 questions, 7 or 8 questions. And it's just as a recap of everything that we've covered so far. So on Monday and Wednesday. Okay, that's great. So I can see people joining. As I said, you don't need to register. So hopefully lots of you can join. It's not like quizzes, so you should be able to. Okay, that's great. So I'll just wait a couple more minutes for more people to join. Let's go to menti.com, 560364. Excellent. I can see lots of people joining. Really great. Okay, so there are 38 of you in here. So I'm not sure how many of you will join the quiz. So I'll wait until we get to about 20 or 25 and then I'll start it. So just give you another minute or so to join. So as I said, if you want to join, menti.com and then use the code 560364. If you've got any questions about that, just put it in the chat function, but I think it should be pretty straightforward. So someone's asking me a medicine related question. So the UK CAT is a medical entrance exam. Which books did I use? Really good question. So I did the UK CAT years ago. I'm now essentially going into my penultimate year of medical school soon. But when I did it, I used the Kaplan book, and I still recommend that book. So I tutor for the UK CAT and I still use that book. But mainly, most people use online resources now. And the online resources, things like Medify, are really good for doing that because the actual exam is online. So I would definitely recommend doing online using online sources. Okay, so I'm going to start the quiz now then. So I've got 23 of you in here. Sorry if no one else has been able to join. You should all be able to join, but we'll start. So the first question is, what does high volatility mean? And the answers are going to come up on the screen now. For those of you that aren't in the quiz, you should be able to see them on the screen. So does high volatility mean that a substance burns easily, a substance becomes a gas easily, a substance has a high boiling point, or a substance flows easily? So if you can't join the quiz, you can send the answer in the question box. Good. So high volatility means that a substance becomes a gas easily. So well done. Flowing is about viscosity. High boiling point doesn't really have a word for it. And burning is flammability. So volatility is a substance becoming a gas easily. Well done. Okay. The next question should be coming up on the screen. There we go. What are the products of the complete combustion of pentane? What are the products of the complete combustion of pentane? So you can see, is it carbon dioxide and water, carbon monoxide and water, or carbon and carbon monoxide? Great. So the answer is carbon dioxide and water. Excellent. Remember, carbon and water is incomplete, carbon monoxide and water is incomplete, and carbon monoxide isn't really an answer. You would never get that. So well done to everyone that gave me the correct answer there. Hopefully the next question will be coming up on the screen now. Why is carbon monoxide toxic? So why is carbon monoxide toxic? Great. Yep. So it decreases the oxygen carrying capacity of red blood cells. So I think some of you might have got a bit tricked there because I put white blood cells. So the answer is red blood cells. So that's just make sure you read the answers carefully. Yep. So it doesn't decrease the carbon dioxide carrying capacity because our red blood cells don't really carry carbon dioxide. They carry oxygen, and it's carbon that irritates the lining of the lungs. So yeah, this answer here that a lot of you gave, I think that's just because you didn't read the answer carefully enough. But well done to those of you that got it right. Okay, which catalyst is used in the cracking of hydrocarbons? Which catalyst? Good. So most of you are saying zeolite. Great. So this is a different type of question. That's why we can see as people are answering. That's really good. Yep. So it's zeolite that's used in the cracking of hydrocarbons. Well done. Okay. What is the name of the alkene with 4 carbons? The alkene with 4 carbons. Good. I think most people are getting it right. Yep, it's butene, not pentene. So people that are saying pentene is 5 carbon atoms. You might be getting confused because pentene is the 4th alkene, but it's got 5 carbon atoms. So this is specifically what's the name of the alkene with 4 carbon atoms, which is butene. So well done, everyone. Okay, so the next question should be coming up in just a second. What is the test for a carbon double bond? What is the test for a carbon double bond? Good. So it turns bromine water colorless. Excellent. So most of you got that. So bromine water starts off brown. That's why that wasn't the correct answer. It turns it colorless. Cobalt chloride paper turning pink is the test for water, and anhydrous copper sulfate turning blue is the test for water as well. So there are two tests for water. So they were tests for water. This is not the correct answer because bromine water turns colorless when it is with a carbon double bond. If it had said single bond, this would be correct. But yeah, the people that got it right, well done. So I think that's the end of the quiz. So we can see the leaderboard now. Well done to everyone. You all did really well, so you can see that there. So hopefully you enjoyed that quiz. If you could just send me a message in the chat function to just let me know if that was better than using quizzes, or was that a little bit easier than using quizzes, just because I just wanted to know, because I think I'm the first tutor to use Menti. So yeah, was that better? Okay, fine. So I'll continue using Menti and I'll let the other tutors know as well. So thank you to everyone that joined that. Okay, so let me just go back to the lesson. We've probably got time for one exam question, so I thought let's do that. Let's start off here then. So propane is used as a fuel. Complete the equation for the combustion, the complete combustion of propane. So I think most people have said that they preferred Menti, so I'll use Menti from now on. I'm glad that you preferred that. So the complete combustion of propane, what does it produce? And they've actually balanced it for you, which is really nice. I'm not sure that you can do the quiz again in your own time, because I think I have to be presenting it. Sorry about that. But if you watch the lesson back, you'll be able to see the questions as they come up on the screen. Yep, great. CO2 and H2O. So I think the hard thing here is just to make sure that you put them in the right order. So if we have a look, there are 3 carbons on the reactant side. So that means it's going to produce 3 CO2 because we want 3 carbons and 4 H2O. So well done, everyone who answered that correctly. Okay, so petrol contains octane. Complete the word equation for the reaction of octane with oxygen. So what happens when octane reacts with oxygen? It's a shorter hydrocarbon. Someone's saying Kahoot is better. The reason I didn't use Kahoot is because it limits the number of people that can join. So that's why I use Menti, because I can have an unlimited number of people joining. So what's the word equation for petrol reacting, for octane reacting with oxygen? So remember, that's a combustion reaction there. Good. Octane plus oxygen produces carbon dioxide and water. Excellent. Well done. Octane plus oxygen. I'll just put CO2 and water. Yep. It says word equation, so you should write them out when you do them. Why is propane useful? So the answers are: propane is a polymer, propane is an alloy, or propane is a fuel. So why is propane useful? Is it a polymer? Is it an alloy? Or is it a fuel? Why is it useful? Good. Propane is a fuel. Remember, all the alkanes produce fuels or are fuels. So well done. So propane is a fuel. What's missing here to produce ethene? What's missing from the structure? What's missing? It's ethene. So what's missing? Good. The double bond. That's all that's missing. So you just need your carbon-carbon double bond there, like that. Great. What is the color change when bromine water reacts with ethene? What's the color change when bromine water reacts with ethene? Good. Orange to colorless. Excellent. Well done. Really great. Okay. Explain why the incomplete combustion of methane is dangerous. So it's our last question for today then. Why is the incomplete combustion of methane dangerous? So I talked to you about this question when we were doing this part of today. So why is it dangerous? Does anyone remember? Good. So someone said it produces carbon monoxide, which is toxic to humans. Okay, so you would get 1 mark for saying it produces carbon monoxide. The second mark would come from saying it limits the amount of oxygen hemoglobin in red blood cells can carry. Excellent. You can also say it produces carbon, which lines the airways and makes it difficult to breathe. So there's 4 possible marks available: either carbon monoxide, which reduces the oxygen carrying capacity of red blood cells, or carbon, which lines the airways and irritates them, making it more difficult to breathe. So well done everyone today. Hopefully you feel that we've covered all of the learning objectives. I hope you enjoyed the quiz as well. I'll try to incorporate a quiz every time that we do a lesson. So we've now covered the topic of alkanes and alkenes. So tomorrow we're going to start looking at some of the other products produced, so carboxylic acids, esters, and alcohols. So we're kind of moving on to a different topic, but it's all linked to organic chemistry. But very well done, everyone. And hopefully I'll see you tomorrow at 3:15. Take care. Bye.
Thanks, Aman, and thanks everyone for engaging with the lesson so well today. That was really brilliant to see. If you join us for other sessions, we have Foundation Maths, Physics and Higher Maths this afternoon. So see you in one of those sessions. If not, see you in our next chemistry session tomorrow afternoon. Bye.
Bye.